Hello everyone. This video is an appendix to my previous video, so it won't make much sense if you haven't looked at the previous one. And it's about the performance testing of the vacuum and the mechanism of the head and what is normal. The first thing which we needed to do is to verify if the suction, the vacuum is sufficient. So I've used just some basic physics just to calculate that. If you would like, you can skip this gibberish and just go to the test, which is a minute ahead.
So this is basically the area of the pipe of the hose, the end of the hose. And I've calculated the average diameter. We need that because it's an oval, it's not a full circle. Next, I've calculated the area of the hose, which is approximately 10.5 square centimeters. Next, the vacuum, which normally these vacuum cleaners produces about 20% drop from the atmospheric pressure, which in the most places in UK is around 1 bar, because it's close to the sea level pressure. So this means that the vacuum, which most of the vacuum cleaners we produce, is about 0.2 bars or 0.2 kilograms per square centimeter when you fully clock the end of the hose pipe. This means that the lift force can be calculated by the vacuum, which is the pressure, multiplied by the area. And we have both. We have the area, we have the vacuum pressure, which is negative in this case relative to the atmospheric pressure. This roughly gives about 2.1 kilograms. So if the main unit of the vacuum cleaner is fine, it should be able to lift about 2 kilograms. Let's go to the test.
For confirming the suction, we can use just the weight. This is 1.25 kilos. As you see, it's not very accurate. So we can add these just to increase the weight. And we have 1.9 kilos, which is good for the test. And now we have to see if this could be actually lifted by the vacuum. It's very important to keep all this thing extended to the end, because if this is not locked, if it's not extended, actually the suction is lower because there is a leakage of the air. So I will turn this on. Stop it gently. So it passed the test, which means that the pressure is definitely like it's supposed to be. Fine for this vacuum. Next step is to verify if the mechanism is spinning freely. So you have to be able to spin it without any obstructions. If you see, I just hold it with 2 fingers and it just spins very smoothly. The other thing, it should have inertia. So when you spin it, it should continue to spin a while. The next thing is the valve. This valve should be open fully, like this. And the air should freely go into this hose, just to spin the turbine. Even though everything may looks right, it can spin freely, the valve could be open, etc, etc, it still can spinning very, very slow and very unpowerful. And I will demonstrate what's the reason of that, especially if you test it in this condition. This rubber is very important, because it actually blocks partial of this pressure, this under pressure, this vacuum to pass through the hole. So basically this should be semi-clogged just to obstruct the air, so to left more air for the turbine. I will demonstrate that now. It's very obvious. See, now it's very, very weak. I can stop it like this. I can shut the valve, it stops. I can open the valve, and it's continuous but very, very weak. So when you put this cover, this was happening. So it's very hard to stop it now. It becomes very powerful. And like this, it's like almost nothing. So it very much depends how you test it. If you test it open, you're never gonna get a nice spinning of the turbine. Another way to test if the airwaves are clean is just to reverse the direction of spinning and just try to blow a candle. You cannot blow it, but you can see definitely that in this direction there's no effect. But when you turn in this direction, it starts actually trying to blow the candle. So if everything is fine, when you're spinning in reverse direction, and when you put, for example, your face here, you'll feel the blowing of the turbine. Last but not least, don't forget that when you attach this to the ground and to the carpet, it blocks additionally the hole here, so it will actually leave more for the turbine. If you block it, it will be even harder. I hope this was interesting and this will be helpful for you. Thanks for watching.